Hello students, we are discussing part test 5 physics solutions. Let's just get started. I hope you have read the question. If not, pause the video and go through the question. What the question is saying is there's a cube and there's a horizontal force which is applied at 1.2 meters. And we need to find minimum horizontal force so that the block rotates about this lower edge. So when the block is just about to rotate about this edge, normal reaction and friction both will pass through this point. So torque because of normal reaction and friction is going to be 0. The other force that is acting is mg. So when torque because of external force is greater than or equal to torque because of mg, it will start to rotate. So we find minimum horizontal force by equating both of them. So torque because of F is F into 1.2 force into the perpendicular distance from the axis of rotation. And torque because of mg is mg into this perpendicular distance, which is simply a by 2. So mg into a by 2. So force into 1.2, mass is given as 3.2 metric tons, which is 3.2 into 10 cube. And the value of G you need to put as 9.8, because if you observe, the options are multiples of 9.8. Now substituting all the values, the value of force will turn out to be 1.96 into 10 power 4 Newton, option C. Moving on to the next question. There is a sphere of mass m, radius r, and the axis is passing through the center. So the moment of inertia is 2 by 5 mr square. The same sphere is cast into a disc of thickness t. Now this is being rotated this way. So in question he mentioned moment of inertia of both of them is same, then find radius. Now for the thick disc, moment of inertia will simply be m, the new radius is r dash square by 2. The mass is going to remain same, so r dash square is 4 by 5 r square, r will be 2 by root 5, or r dash will be 2 by root 5 r. It will be option A. Now given in the question alpha is 3 radians per second square, initial angular velocity omega naught is 2 radians per second, it is rotated through an angle in 2 seconds. So you need to find theta, which is omega naught t plus half alpha t square. Omega naught 2, time is also 2 plus half, the value of alpha is 3, 2 square. Substituting all the values, we are going to get 10 radians. So option B. Now in the next question, a particle of small m is hitting at midpoint. So we solve this by conservation of angular momentum about this point. Angular momentum is only conserved about the hinge. So angular momentum initial equals to angular momentum final. What is the initial angular momentum? mv into this perpendicular distance, which is going to be L by 2. Now after the collision, this small m has come to rest. Only the rod rotates, let's say, with angular velocity omega. So after collision, angular momentum will be I omega, which will be capital M L square by 3 into omega, small m into L by 2. L and square cancel. This is small m and this is capital M. We need the value of m by m. So m by m, capital M by small m will be 3 by 2 and omega L. Now we need one more relation. To get one more relation, we're simply going to write E equal to 1 because it is an elastic collision. So velocity of separation by velocity of approach is 1. Velocity of separation, the rod is going to get separated or move away. Here the velocity will be omega L by 2. So omega L by 2 must be equals to initial velocity v. Here m into L by 2 into v. So here we have one v. So this is v. Omega L by 2 is v. So multiply and divide by 2. These are same. So capital M by small m is 3 by 4, which will be option A. Moving on to the next question. So there is a sphere which is rotating about the diameter and it is heated. Now when it is heated, it is going to expand and some of the mass is going to be at the outside, which will increase its moment of inertia. So we solve this question by again conservation of angular momentum. I1 omega 1 equals to I2 omega 2. And here if you observe, we need fractional change. This is a typo, we need fractional change. So I omega is constant. So I is constant by omega. Di by I is d omega by omega. We need d omega by omega, which is nothing but di by I. I equals to 2 by 5 mr square. 2 by 5 m is constant. So di by I is simply 2 times dr by r. Now just going to add a slide. So we need to find dr by r. Now if it is heated, it is simply r alpha delta t. So dr by r will be alpha delta t. So di by I will be 2 alpha delta t, which is equal to d omega by omega. That gives us option A. Sorry. Yeah, option A. Now they are asking, will time period change or will it remain same? So the only point in the question is, even if the block is horizontal or vertical and you displace it by same amount, their mean position could be different, but their time period will be same. So the two systems will have identical time periods irrespective of the weight of the spring. The weight of the spring is not going to matter. In both the cases, it will be 2 pi root m by k. M and k identical springs, so they are same. Now we need Young's modulus. So this is stress strain curve. The slope of this line is nothing but Young's modulus. So Young's modulus is tan theta. So YA is tan 60, which is root 3. YB will be tan 30, which will be 1 by root 3, which makes YA is 3YB. Option D. Now, in this question, he's just testing you if you know that irrespective of the container, shape of the container, if the level of water is H, the pressure is going to be rho g H. So force is going to be simply pressure into area, rho g H into area. So if we substitute all the values, we're going to get 7.2 Newton. Now a liquid flows through the horizontal A1 and A2. Which of the statement is wrong? So when you apply Bernoulli, P naught plus half rho V square plus rho G H equal to, let's say V1 H1, P naught plus half rho V2 square plus rho G H2. Now the pressure is going to be same and they are at the same height, so we need velocity in terms of height. They are at a different height. So this is H1 and this is H2. So when you send this to LHS, rho G H2 minus H1 is simply H, half rho V1 square minus V2 square. Just applying basic Bernoulli, we will get V1 square minus V2 square, or in this case H2 is the higher one, so V2 square minus V1 square will be 2 times GH. So option C is correct, which will make definitely option B wrong. And option A, A1 V1 equals to A2 V2 equation of continuity, he's saying the volume flow per unit time is A1 V1, which is correct, and energy per unit mass. So from Bernoulli we know that energy per unit volume is same. So since density of the liquid is not going to change, energy per unit mass is also going to remain constant. Now for the next question, you have two wires of same material and same mass. So mass is same, material is same, which means Young's modulus is going to be same. Now Young's modulus is nothing but F by A, that is stress by strain, delta L by L, which is going to be FL by A delta L. Now here he mentioned mass is constant and the material is same, so their density is going to be same. If their density is same, mass is same, volume will also be same. Now if you multiply L in numerator and denominator, this will become FL square by volume into delta L, and since Young's modulus is same for both, delta L is FL square, volume is constant by this. So delta L proportional to L square, elongation is proportional to length square. So their lengths are in ratio 2:3, their elongation will be in ratio of their square, which will be 4:9. Now in the next question is saying kinetic energy is equal to potential energy. The kinetic energy half mv square, half kx square if you consider spring, half m. Velocity is nothing but a omega, let's say cos omega t whole square, a square omega square cos square, half k, x a sin omega t, a square sin square omega t, k is m omega square, half a square. Basically you'll get cos theta equals to or sin omega t equal to cos omega t, which means angle is 45 degrees. So x equal to a sin omega t, a by root 2. Moving on to the next question, you placed a sphere, so density of oil and mercury, such that half is here and half is here. So here the simple concept is buoyant force must balance mg. What is the buoyant force exerted by oil? Rho oil, only half the volume is inside, rho v by 2 into g. So this is density into volume, which will give mass into times gravity. Buoyant force, rho vg. Rho mercury, volume by 2 into gravity, must be equal to rho of the material, capital M, v into g. Vg cancel. So rho of material is rho of oil plus rho of mercury by 2. So 13.6 plus 0.8 by 2, which will give us 7.2. Now there are two drops, they are combined to form a bigger drop. So initial volume equals to final volume. What is initial volume? 2 into 4 by 3 pi capital R cube. Final volume will be 4 by 3 pi R dash cube. 4 by 3 pi cancel. The new radius is 2 power 1 by 3 into R, and we need the new surface energy of the bigger drop. So surface energy is simply surface tension into 4 pi R square. So T into 4 pi and R square 2 power 2 by 3 into R square. Now 4 is 2 square, 2 power 2 plus 2 by 3 into r square. So 2 power 2 by 3 will be 2 power 8 by 3, which makes it 2 power 8 by 3 into tension into pi r square, which is option C. A particle is performing SHM. Time taken to go from mean position to a by 2 is t1, a by 2 to a is t2. So we have a spring, it is in mean position. From a to a by 2, it is t1. Let's say x equal to a sine omega t. Why sine omega t? Let's say initially it is at mean position, now it is going to a by 2. So x equal to a by 2 sine omega t. 1 by 2 is sine omega t. So omega t is pi by 6. Now this t value is, we need to find the t value. So t is pi by 6 omega, which is t1. Just a second. I'm going to add one slide. And in the next case, it is already at a by 2. You need time taken to go to a. So a equal to a sine omega t. Omega t will be pi by 2, t will be pi by 2 omega. So t2 is, so time taken to reach a by 2 is pi by 6 omega. So time taken to go from mean to a minus time taken to go from mean to a by 2 will give you t2. So pi by 2 omega minus pi by 6 omega. Now we have to verify options. So if you verify options, clearly t1 is not equal to t2. This is also not going to match. T2 is greater than t1. Option A is going to match. No. There's a small insect which starts going away with constant speed. Now, on the rod, when the insect moves away, what happens is its moment of inertia is going to increase. Moment of inertia is moment of inertia of rod plus m capital R square, isn't it? So since moment of inertia is increasing, you need to find torque versus time graph. Now nothing about force or anything is mentioned. So the relation that we are going to use is torque is dl by dt, rate of change of angular momentum. So what is angular momentum? Now, since no external force is right. Now what is angular momentum? Angular momentum is of moment of inertia of rod plus mr square. Now what is this distance r? It is simply v into t, velocity into time, which will be v square t square. So when you differentiate, you will get 2mv into 2t. So dl by dt is proportional to time. So angular momentum increases as the insect moves forward, and after it has reached the corner, it has come to rest. So moment of inertia will stop changing and angular momentum will stop changing. So it will be 0 after it reaches the end of the rod, which makes our answer option B. Right, there's a pulley of radius 2 meters. The force acting is 20t minus 5t square. So the torque is going to be 20t minus 5t square into 2, 40t minus 10t square. Now this is the torque. We need to find when it will reverse. So we'll find alpha, we'll find omega. When omega, that is its angular velocity, when it changes its sign, that is when the direction of motion will be reversed, isn't it? So what is torque or what is alpha? 40t, and it is given I is 10, so 4t minus t square. Now when you integrate this, you're going to get omega, so which is going to be t square by 2, so 2t square minus t cube by 3. Now when will it change its sign? So when will this omega become 0? So if you take t square common, 2 minus t by 3, so at t equal to 6, omega is 0. So until 6 omega is positive, after 6 omega is negative. So that is when it's going to change its sign. So at t equal to 6, we need to find angular displacement theta. Basically we need to find number of rotations for which we need theta. So theta is going to be, integrate this, t square integration will be t cube by 3 to t cube by 3 minus t power 4 by 12. Substituting t equal to 6, we're going to get 36. Now this is angular displacement is in radians. We need number of rotations. So number of rotations will be theta by 2 pi. In one rotation, it will make 2 pi radians. So number of rotations will be theta by 2 pi, 26 by 2 pi. This is around 6.28. So this is just little less than 6. So less than 6, more than 3. Moving on to the next question. Right. So m1 goes down, m2 goes up by h. We need to find angular speed of the wheel. The best way to solve this question is by conserving energy. Now what is the energy lost when m1 goes down? m1 gh. m2 going up, it gains energy, so the net energy lost is m1g minus m2g into h. Now this must be equal to half I omega square plus, now m1 and m2 are going to move with same velocity, so their kinetic energy will be given by half m1 plus m2, just a second, half m1 plus m2 into v square. Their velocity is same because of the string constraint. Now look at this point. If there is no slipping, here the velocity of this point on pulley will be r omega and the velocity on the string should be v. So v must be equal to r omega. And we need to find omega. So we will substitute v is r omega in this equation. So we'll add one slide. So the equation is m1 minus m2 into gh is half I omega square is half m1 plus m2 into v is r omega, r square omega square, half, you can send this 2 here. You can take omega square common. When you take omega square common, you'll be left with I plus m1 plus m2. And when you send this to LHS omega 2 square is m1 minus m2 into gh by I plus m1 plus m2. Right, m1 plus m2 into r square, this r square, which makes it, just a second, b2 into m1 plus m1 minus m2 into gh by this. Right, now we have liquid. The problem with the liquid is that its density is changing. Now its density is changing at distance z. So this cylinder is along z. So what we are going to do is, we need pressure at the bottom. So pressure at the bottom is simply the mass above mg, force applied by area, and m is simply rho a into h by a. So a will get cancelled, but the problem is rho is changing. So let's just say the small pressure that is applied by here is rho there, rho at function z. We are going to take a small disk of radius dz at a distance z. So what is going to be the volume of this small disk? It is going to be pi r square into dz, area into thickness. So its area term got cancelled here, which leaves us with the small thickness dz and g. Just adding a slide. So this will be small pressure dp, complete pressure from 0 to z, pressure at the bottom will be integral 0 to z, or g, the final pressure will be p 0 to z, which is given as h. So p is integral 0 to h p naught into 2 minus z by h whole square into dz. G is anyway constant. Now when you integrate, rho naught also constant, rho naught g. Integration of 2 will be 2z, z square, z cube by 3h, 0 to h. When you substitute 0, it is going to be 0. And when you substitute capital H, rho g, this is 2h, h cube this will be h square whole square, so it is going to be h by 3. 2h minus h by 3 is 5h by 3. So this is going to be the pressure at the bottom, and pressure at the top is going to be 0. So the difference in pressure will be 5 by 3 rho g, rho naught g h. This is rho naught. Just a second. Right. Find the minimum value of v. Now the sphere is rolling and going up. So the sphere is rolling and going up. The center of mass of the sphere is at distance small r, and at the final position it is also at distance small r. See, if you look at the highest point, this one A, the forces acting are mv square by r upwards, mg downwards here. So if it just needs to make it up, mv square by r must be at least equal to mg, which will be v square should be at least equal to rg. So the minimum velocity at the topmost point is rg. Now since there is no friction, we are going to conserve energy. Now while conserving energy, what is the height that it gains? This distance is 2 capital R. This is, sorry for that, this is smaller, so this distance will be 2 times capital R minus small r, right? Now we are going to conserve energy. Now since the just adding a new slide. Right, since the object is rolling, energy at 1 must be equal to energy at 2 because there is no energy loss. And since the object is rolling, what is energy at 1? Half mv square into 1 plus k square by r square. That is translational kinetic energy plus rotational kinetic energy. This is the initial velocity u. And k square by r square for solid sphere is going to be 2 by 5. Now finally at this point it has gained potential energy as well as kinetic energy. So kinetic energy will be half mv square into 1 plus k square by r square plus potential energy gained is mgh. Now half m here will get 2, and since v square is rg that we just found, this is 1 plus 2 by 5 7 by 5, this will be 7 by 5 rg plus, and what is the value of h? The value of h is 2 into capital R minus small r, right? And this r will also be same as that. So just a second, out of battery. Right, when you write mv square by r, this is the radius, so the radius is going to be r minus r, so this will also be r minus r. So 7 by 5, v square is r minus r into g plus 2 into g into 2 capital R minus small r, and this will be u square into 7 by 5. Simplifying, you will get, sending this to RHS, you will get u square is 27 by 7 g into r minus r. Send this to RHS. Yeah, so that will make it option B. Moving on to the next question. Now mercury is, if it is at the same level, pressure exerted by oil equal to pressure exerted by water. Rho water G into 10 centimeters equal to rho oil G into 12.5 centimeters. Rho G. Sorry, rho W, we need GG cancelled. We need relative density of oil, that is relative oil density by water density, which will be 10 by 12.5, which is going to be 0.8. Right. Now we have uniform spherical shell which is rolling down the incline. What is its angular momentum after 1 second? Now when it rolls down, its linear acceleration is g sine theta by 1 plus k square by r square. Standard result. K square by r square for spherical shell is 2 by 5. So it is g sine theta by 1 plus 2 by 5 will be 7 by 5. Now what will be its velocity, linear velocity of center of mass? U plus at. Initial velocity is 0. Acceleration is g sine theta, which is nothing but g by 2 by 7 by 5 into t. Now we need angular momentum about point of contact. That is why I have calculated velocity of center of mass, so that we can find angular momentum. Just we will add one slide. Yes, now here the sphere is rolling, its velocity, it is moving with v. You need angular momentum about this point of contact. Angular momentum about any other point will be angular, just a second, angular momentum about point of contact will be angular momentum of center of mass plus angular momentum about center of mass. So what will be angular momentum of center of mass? It is going to be, now you can kind of assume this center of mass, entire mass, to be moving with velocity v. So mv, and the perpendicular distance is going to be r, plus angular momentum about center of mass. What will be angular momentum about center of mass? That is, you're standing here, it is rotating with omega, so it will be I omega. So mvr, I, moment of inertia, 2 by 5 mr square. Omega will simply, v is r omega since it is rolling, and omega will simply be v by r cancelled. So basically you will get mvr into 1 plus 2 by 5. And what is the value of v? The value of v is g by 2. The value of v will be g by 2 by 1, that 1 plus 2 by 5, 7 by 5. This and this cancel, g by 2 is 5. So the value of angular momentum is 5 mr. With this, okay, numerical kmr, the answer will be 5. Now gravity free space, it is given velocity v, it is given speed v, and spherical object, and it is given coefficient of viscosity is 1 by 6 pi. So the resistive force on spherical object is given by 6 pi eta rv, and minus indicates that the force is in opposite direction. Eta and 6 pi, eta is 1 by 6 pi, so the force is simply rv. Now we will simply write force equal to minus vr, force ma dv by dt minus vr, so dv by, we need displacement. If we need displacement, we need not calculate velocity, we can directly calculate x coordinate. So f is minus vr, so we will write mass into acceleration, v dv by dx minus vr, v cancel, we need x, so minus r dx is m dv, integrating on both sides, send this here, x is simply minus mv by r. Now he gave the distance traveled, x equal to minus mv by r simply indicates that the displacement is negative. So z and y, z equal to 1, y equal to 1, 1 plus 1 is going to be 2. Moving on to the next question, we have damped oscillations. So net force equals to minus BV minus Kx. So the solution, if you observe, this is a second order differential equation in X, and the solution for this second order differential equation is going to be X as a function of time is a naught e power minus b by 2m a naught e power minus b by 2m into t into cos omega t plus 5. Now if it is initially at the extreme position and this is cos function, phi value will be 0. Now he's saying amplitude falls to 3/4 of initial value after 4 oscillations. So amplitude will become 3/4 of initial value omega at t equal to 0 cos omega t 1 multiples of time period cos omega t value will be 1. This will be a naught e power minus b by 2m into t. Now when you take ln on both sides, ln 3 by 4 is given as 0.28 minus 0.28 minus 0.28 is minus b by 2m. Now 4t, time is given as 4 times time period. Now m is 2, just a second, 2m, m is 2, so this both will get cancelled. Now we need time period value. How to find time period value? For that we have omega equals to, in the same solution this omega is nothing but omega equals to under root k by m minus b by 2m whole square. See, after 4 oscillations its amplitude only became 3/4, meaning the damping constant is less. So b by 2m, if you approximate to 0, omega is under root k by m, under root k is 8 pi square, m is 2, root 4 pi square will be 2 pi, omega is 2 pi, which means time period is 1. So time period is 1, so b value will be 0.28 approximated to 0, so the answer will be 0. Two pendulums of length 1 meter and 1.21 swinging together with same amplitude. Number of vibrations until both will swing together. So time period is 2 pi root L by G. Time period is proportional to root L. So T1 by T2 is under root 1 by 1.21. So 1 by 1.1. So T1 by T2 is 1 by 1.1, which is 10 by 11. See, here he is saying when will they swing again together. So the time period is some constant into 1 and T2 is some constant into 1.1. So it will take 1 second into some constant to complete one oscillation. For the second one it will take 1.1. Now, so 1 and 1.1, if you say the time periods are just multiplying some constant. So both, when time will become 11, 1 times 11, it will also complete oscillations. 1.1 times 10, it will also reach the same initial position after completing 10 oscillations. Now the longer number of vibrations executed by longer pendulum 1.1 into 10, when it makes 10 oscillations it will again reach the initial point coinciding with the smaller pendulum. So your answer is going to be 10. Now we'll conserve energy to find the angular speed. Just a second. Right, this is theta, this is L by 2, So this height is L by 2 sine theta. So what is the potential energy it lost? mgh. H is L by 2 sine theta, which is nothing but energy gained. Now the energy gained by rod is purely rotational, so half I omega square, half ml square by 3, moment of inertia about 1, and into omega square, m cancel. Sine 30 will be 1 by 2, g 10 into L by 4. Here you have 6, so 6 will come here, ln square L omega square, and L is given to be 1 meter. Now calculating omega square is going to be, this is 3, 15, omega will be root 50, so a value of n is 50.